Hello everyone, class 12th. Topic is reduction of aldehyde and ketone to prepare alcohol. In the series of preparation method of alcohols, we have next preparation method, reduction of aldehyde and ketone. Let's check. First of all, we should be clear about the aldehyde. This is aldehyde. And this is ketone. Where R is representing alkyl group or it can be aryl group, means benzene ring. Same here, R are representing alkyl groups or aryl groups or one alkyl, one aryl. These are aldehydes and ketone. Now, if we reduce them, they can give us alcohols. The first direct shortcut, let me tell you. When I am saying reduction, in 10th class, we have done reduction definition, add of hydrogen and loss of oxygen. These are the definitions for reduction we have. We can use them here to understand the topic very easily. Like what to do? Between carbon and oxygen, we have two bonds. Next time, if you will reduce them, means if you are doing reduction of aldehyde, check this. I have reduced it. Two bonds were there with oxygen. After reduction, only one bond is there. So what I have applied? Loss of oxygen. Means bonding with oxygen is decreased. But is it final? No. We have to satisfy their valencies. Oxygen always make two bonds. So second bond will be with hydrogen. Carbon always make four bonds. So fourth bond will be with hydrogen. Now check. Loss of oxygen I have written there and add of hydrogen. Hydrogen is added with this carbon and here with oxygen. Now check. This is the product which I got, that is alcohol. So after reduction of aldehyde, I am getting this alcohol. What is the degree? Always the degree will be 1 degree. After reduction of aldehyde, always you will get 1 degree alcohol. Same technique you can apply here directly. If we have to reduce it, so decrease bonding with oxygen and satisfy valencies with hydrogen. Now check, alcohol is generated, OH is the functional group over here. Now it is a 2 degree alcohol. How to check degrees of alcohol? In previous videos we have already understood. So after reduction of ketone, we will get 2 degree alcohol, and after reduction of aldehyde we will get 1 degree alcohol. Okay. Now for reduction we know what we require. We require reducing agents, the chemicals which can reduce aldehyde or ketone up to alcohol level. So reducing agents you can use, note down. Reducing agents are, you can use direct hydrogen gas in the presence of some catalyst like nickel metal or platinum metal. Second, sodium in the presence of ethanol, C2H5OH. This can also work as a reducing agent. Third, lithium aluminum hydride. After lithium aluminum hydride, you have to apply hydrolysis process. Fourth, sodium boron hydride you can use, and after that again you have to use hydrolysis. So these are the reducing agents which you can use to convert aldehyde into alcohol or ketone into alcohol. Like in board, if reaction is given CH3, CH2, COH, and in reaction it is written NaC2H5OH. So just you have to learn it. It's a reducing agent, means you have to do reduction of that. Reduction technique I have already told to you. Two bonds are there. Loss of oxygen means break one bond from oxygen. Make it single bond H and satisfy rest valencies with hydrogen. So propane 1-ol will be generated. In this fashion, you have to complete the reactions in board. Learn these reducing agents. Now, we are going to talk about the next level work of that mechanism. Reactions we can solve very easily, like suppose this reaction is given to me. First, I need to understand what it is a ketone, and if it is written lithium aluminium hydride over here, so directly it is understandable to me it's a reducing agent, it's a ketone. I have to do reduction of that. So what I will do, two bonds are there, one bond I will make, that's it, and valencies I will satisfy by hydrogen. Alcohol is generated. What will be the name? 1 carbon, 2, 3, 4, 5. Numbering will be from this side 1, 2. So it will be 5 are there. So pentane 2-ol. In this fashion, we can solve these reactions very easily. But let's go for the mechanism, how reducing agents are working there. First, I am going to apply the reducing agent, this one, hydrogen in the presence of catalyst. Hydrogen gas in the presence of catalyst like nickel metal or platinum. First, these catalysts. These metals have rough surface areas. Suppose nickel I am using. So nickel metal will provide rough surface area. Rough surface area. On that rough surface area, the hydrogen gas particles will be adsorbed. Adsorbed means they will sit on the surface of the metal. They will not go inside of that. If they are going inside metal, we will call it absorbed. They are not absorbed, they are adsorbed. Okay. Now, in this condition, what will happen? Their bonding will become weak. Like 2 electrons are there. So their bonding between them will become weak. Now, aldehyde particles or ketone particles, how they will react with them? CO part will come. One electron is here, one electron is here. So they will start joining with oxygen and carbon like this. One electron will toward carbon, one electron toward oxygen, and bond formation will be generated. Carbon will combine with hydrogen, oxygen will combine with hydrogen, and RCH OH will generate out. And obviously this product will leave the surface. Product will leave the surface. This is the mechanism of hydrogen gas in the presence of catalyst. In this fashion, it will reduce aldehyde or ketone. I have used aldehyde here. You can use ketone. Ketone, try by yourself. Second reducing agent, that was sodium and C2H5OH. Look how it is working there. We know sodium is a metal going to lose one electron. This one. Sodium always have a tendency to lose electron. Not only sodium, other metals also lose electron. Now where this electron will go? I am using aldehyde. You will try by ketone, with ketone by yourself. Same mechanism it will be. Now understand this group, CO group. We call it carbonyl group. It is available in aldehyde, in ketone, in ester, in carboxylic acid, in amides, it is available. Now in this, because we know oxygen is more electronegative than carbon, so this carbon is carrying positive charge, oxygen is carrying negative charges with 2 lone pairs over there. Obviously, the electron generated will go toward a positive particle. Let's move it. Bond will break. Which bond will break? Pi bond. And both electrons will get shifted toward oxygen because oxygen is more electronegative than carbon. So now on oxygen we will have 3 lone pairs and extra negative charge will generate because the oxygen got one extra electron of carbon. And what about this carbon? In its fourth orbital, one electron will come here. This electron. Like this. Now, alcohol, C2H5. We know alcohol is little bit acidic in nature. How? Because alcohol particle will lose H positive because this hydrogen is connected with oxygen and oxygen is highly electronegative as compared to hydrogen. So this hydrogen is highly positive. Oxygen is negative. So in ethanol, oxygen hydrogen bond will break and both electrons will shift toward oxygen, due to which H positive ion will release out. This H positive ion will combine with this oxygen to give us this particle. Now, is it a final product? No, wait. Another sodium, this sodium is used. Another sodium will donate electron, again Na positive and one electron. Now this is unpaired electron. In one orbital, maximum 2 electrons can be filled. Here we have 1. So this one more electron will come here and fulfill the orbital and will make it RCOH H negative, like this. Now who will satisfy this negative? Same, another particle of C2H5. C2H5, another particle, second molecule, will again give H positive and those H positives will combine with that, and finally, let's write it here, RCOH HH. This will generate what it is? Alcohol. 1 degree alcohol. Same mechanism you will apply for ketones. What about these Na positives which are generated? Na positives will combine with these particles. C2H5O negative was generated because oxygen got electron from hydrogen side, so it will carry a negative charge. Na positive, this O negative will combine and they will create sodium ethoxide, C2H5O negative, Na positive. Between Na positive and O negative, ionic bond will be there, sodium ethoxide. Similarly, this Na positive will be satisfied by second C2H5O negative particle. This one. So this is the mechanism we have for sodium and ethanol. When they are working as a reducing agent, they can reduce aldehydes and ketones in this mechanism. Now third and last. Why I am saying last? Because lithium aluminium hydride and sodium boron hydride, they will work with the same mechanism. Okay, so once please understand for lithium aluminium hydride, then apply it for sodium boron hydride. Same it is. I am using lithium aluminium hydride. First we need to understand lithium aluminium hydride condition. Aluminium hydride is in this condition. 3 bonds are covalent and fourth bond is made by a hydrogen that will be dative. Obviously 2 electrons will also there, and -1 charge is on aluminium because aluminium is getting 1 extra electron from hydrogen. Normally aluminium can make 3 bonds, which it is making like this, because normally aluminium have 3 unpaired electron. In this condition it have a vacant orbital. That vacant orbital was filled by hydride like this, due to which we got this one. So fourth hydrogen is making dative bond with aluminium, and 1 electron which this hydrogen was carrying extra, so that electron is shifted toward aluminium. That's why aluminium is getting -1 charge over here. This is the condition of aluminium hydride. The negative charge is balanced by lithium, who is carrying positive charge in this fashion. The same condition will be in sodium boron hydride. Boron is making 4 bonds with hydrogen. Negative charge will be on boron, and that negative charge will be satisfied by Na positive. Now what it will do? During reaction, obviously aluminium hydride is unstable. Negative charge is there on aluminium. It will break bond from hydrogen. Hydrogen is more electronegative than aluminium. Both electrons will go toward hydrogen, and due to which the molecule will become this vacant orbital, because electrons are going toward hydrogen. So here vacant orbital will generate, and this hydrogen will become hydride again. This is hydride. Now hydride is a negative particle, wants positive particle. Where we have positive particle? Let's check. Aldehyde is there. I am applying this mechanism of aldehyde on aldehyde. On ketone you will apply by yourself. Already I told you, in carbonyl group, carbon is a positive particle and oxygen is a negative particle. Because oxygen's electronegativity is more than carbon, so all electrons of bonds are toward oxygen side. That's it. This is positive particle. This is hydride. Will attack on it. Due to which these pi electrons will completely transfer toward oxygen, and fourth bond of the carbon will be generated with hydrogen. The next condition will be this. Now oxygen will carry 3 lone pairs with a negative charge. Who can satisfy it? Watch here. Aluminium trihydride is available with a vacant orbital. Vacant orbital, lone pairs, it will combine with it. Due to which we will get this compound. Between oxygen and aluminium, which bond will generate? Dative bond. Lone pair, vacant orbital, like this. Now because aluminium again getting one extra electron, out of these 2 electrons, one electron will be toward aluminium and 1 electron will be toward oxygen. So aluminium is gaining 1 extra electron. That's why again a negative charge will generate over it. Now what this molecule will do? Check. I will write it again. Now this molecule is ready. Again your aluminium is unstable. How it can get stability? Same technique. It will break bond from another hydrogen, and both electrons will go toward hydrogen because hydrogen is more electronegative than aluminium. When hydrogen will break bond from here and electrons will go toward hydrogen, here vacant orbital will generate, 2 hydrogens will remain as it is, and negative charge will finish. The negative charge was due to 1 extra electron, and 1 electron hydrogen got it with it, and that's why the aluminium will have 0 charge over here. But what about this hydrogen? It will release out as hydride again. Now what this hydride will do? What it will do? It will attack on another particle of aldehyde. Second particle of aldehyde. Same mechanism. Positive, negative. Pi electrons will transfer toward oxygen, due to which what will generate? RCHHO, 3 lone pairs, negative, like this. Now what it will do? Same. Vacant orbital is there. Still we have a vacant orbital. Again the second particle, this second oxygen negative particle will make a dative bond with aluminium. So now aluminium will be surrounded by two such particles. Let's draw it. This is the condition of aluminium. Now because again oxygen, second oxygen has made a dative bond with it, so again a negative charge will generate. Again it will become unstable. Again it is unstable. How it will get stability back? Same technique. Another hydrogen it will lose in the form of hydride. What that hydride will do? It will attack on third particle of aldehyde. Same mechanism. RCHHOO negative. What that O negative will do? Because hydrogen is released out from here, vacant orbital is generated. This oxygen will again attack on aluminium. Which bond will generate? Dative bond. In this fashion, don't you think 4 oxygens can join? Yes, 4 oxygens will join there. Try by yourself. Up to 2 I have drawn. Third and fourth, try by yourself. And then after addition of 4 oxygens on aluminium, our aluminium will be in this condition. Negative charge. This we have. This is known as aluminium alkoxide intermediate. Aluminium alkoxide, alkyl and oxygen, alkoxide intermediate. Is it our final product? No, we want alcohol. How we can get alcohol from here? A very simple process which we call hydrolysis. I already told you what is the meaning of hydrolysis. With the help of H positives and OH negative, we will break bonds in this molecule. H positive, OH negatives we can get directly from water, or we can get it from dilute acids, or we can get it from dilute base. All these 3 conditions can provide us H positive or OH negative. Means with these 3 conditions we can do hydrolysis of any molecule. Okay. Now suppose we are doing hydrolysis between aluminium and oxygen, which is more electronegative? Oxygen. So obviously these electrons are more toward oxygen, so oxygen is negative particle over here, and aluminium will be a positive particle as compared to oxygen. So that's it. H positives will attack on oxygen, bond will break, both electrons will go toward oxygen side like this. And when this will happen, let me make first alcohol RCH2, and this oxygen will join with H. Check this particle. Alcohol. What is the degree? 1 degree. Similarly, hydrolysis of this particle will happen, bond will break. Hydrolysis of this particle, bond will break. Hydrolysis of this particle, bond will break. In this fashion, 4 alcohol particles will generate out here, and this aluminium will turns to aluminium OH4 negative. This one. Aluminium hydroxide negative particle, which will be balanced by lithium positive. It is a side product. The main product will be our alcohol. 1 degree alcohols will generate out here. That's it. These are the mechanisms we have for reduction of aldehyde and ketone. Ketone you will apply by yourself. Check, same mechanism it will be. And I told you the shortcut techniques by which directly you can complete the reaction, and also I have told you mechanisms there. Reducing agents, you can use hydrogen gas in the presence of catalyst, sodium in the presence of ethanol, and third lithium aluminum hydride, and fourth is sodium boron hydride. Sodium boron hydride and lithium aluminum hydride have same mechanism. That's it. Thank you very much.